let's say you came across this type of equation for the first time as a Jambite. Let's take a look at what we have on the whiteboard together. Are you a student who is willing to sit for the forthcoming examination? This particular video is for you. Now, how many structural isomers can be drawn for the non-cyclic alkanol with molecular formula C4H10 oxygen? The first thing you need to identify here is what is the name of this compound. And as I've told you earlier that isomers, they have the same molecular formula but different structural formula. Now, let's take a look at the name of that compound. We have C4H10, we have oxygen. If you are to remove one hydrogen from this place, you'll be having 9. Then add the hydrogen to this oxygen, we have OH. This compound is called butanol. Now, from that butanol, which it is been mentioned in the question that the non-cyclic alkanol, if it is cyclic, we know it is in this form, but non-cyclic, that is, show us the structure of the open chain isomer. That is the meaning of that. So guys, for this, what is that first compound we are going to have as far as it involves non-cyclic? So guys, we have the first one. What is the structural formula of this? I have H here, H. The OH is placed here. I have the fourth carbon. So now, before you name any compound, you need to calculate the number of carbon atoms you have, the number of hydrogen atoms you have, to check if it's the same thing with the molecular formula given. Now let's check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, 10, which is equivalent to this, 1 oxygen. If you are to name this compound, the rules of alcohol is that you start the numbering with the lowest number attached to the functional group. If you are to start from this side, you said you have 1, 2, 3. 3 is attached to this OH, which is the functional group. But if you are to start from this, my left hand side, you said you have 1, 2. 2 is attached to the OH, which is the lowest value. In that case, you said you have butan 2O or 2 butanol. Are you with me now? We have butan 2. The 2 is on this OH. 1, 2, 3, 4. 4 carbon is butanol. So the 2 is on the OH, which is the O. That is why we have it as butan 2O, or we have 2 butanol. So let's take another isomer we can find under this. I have C. So we have this. We have this. We have this. OH. Now, let's count the number of hydrogen if it is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The oxygen is this. So now, 4 carbon atoms, 1, 2, 3, 4. You are still under butanol. So in that case, the number attached to this is 1. So either we'll call it butan 1 or we call it butanol. Is that clear? So now, we have 2 isomers already. And according to the option A 1, option B 2, option C 3, option D 4, is this the final destination of this question? No. In this butanol, we can still find another compound there. So in that case, I'm going to make use of this. See, don't forget in my previous video, when we pick this one with 4 carbon atoms, move it to the one with the second carbon atoms, then by doing so, this will replace the CH3. So we said we have CH3, H3 that is coming in, the hydrogen has going to replace it. We have OH and I have CH3. The longest carbon continuous chain is 3, which is propanol. Now, 1, 2, 3. The number attached to the OH and the substituent methyl is 2. So we said we have 2 methyl, the longest chain, propan, 2-O. I repeat, the longest chain is propanol. These two methyls, propan, 2-O. The methyl here, the 2 here affect it as well. So we have 2 methyl, propan, 2-O. Is that the final solution? No. So let's have the last one. I said, okay, back to this now. Back to this. You don't have to panic as far as this particular structure is given. Is that clear? Now, what is that last value we can have, or last structure we can have? So guys, we said we have CH3, CH, your CH3 is here, you have CH2OH. Let's see if it is complete. 1 carbon, 1, 2, 3, 4, 4 carbon, 3 plus 3, 6, plus 1, 7, plus 2, 9, plus 1, 10. Again, 3 plus 3, 6, plus 1, 7, 7 plus 2, 9, plus 1, 10. Guys, so if we are to name this type of a compound, we said we have 1, 2, 3. 1, 2, 3. Because of this functional group, we need to start the numbering from here. So in that case, we said we have 2 methyl, propan, 1-O. How you say it now? So guys, if you observe, according to the question, we are only asked that how many structural isomers can be drawn from butanol. We have 4 isomers that can be drawn from butanol. In that case, option D is the correct answer. The first isomer, butan 2-O, or we said butan 1-O, can be the first isomer. So we said from this, what we have on the board, the first one I have is butan 2-O, the second one I have is butan 1-O, the third I have is 2-methyl propan 2-O, and the last one is 2-methyl propan 1-O. So guys, this is how you tackle or you attempt any related question that deals with non-cyclic alcohol or alkanol. In case you come across it either in pentanol or hexanol, this video will guide you on how you can easily go about that of the pentanol and that of the hexanol. Guys, if you are just coming across my video, do well to subscribe to my YouTube channel, follow us on our TikTok page, share, like, repost our video, and if you have any question, do well to drop it in the comment box. Thank you and God bless.